let's talk about graphing. Now, when we're graphing, we're actually going to start with the same 4 things that we started with in last lesson when we were graphing exponentials. We have domain, x-intercept, y-intercept, and asymptotes. Now, the x-intercept and y-intercept will actually be exactly the same as we did last lesson. Where the x-intercept, you set the equation equal to 0, and the y-intercept, you plug 0 in. So let's figure those out real fast. For our x-intercept, let's get the log by itself. So then we can change the form. So now that we have that, let's change the form. So base stays the same. Input and output flip places. 3 to the negative 1 is going to be 1/3. Bring it down and make it positive. And we minus 1. 1/3 minus 1 is negative 2/3. And now we can either divide by 1/2 or we can times by 2. They both will cancel out. So 2 times negative 2/3 is negative 4/3. So our x-intercept is going to be at negative 4/3. Now let's look at our y-intercept. We plug 0 in. So log base 3, 1/2 times 0 is 0, plus 1 is 1. We know that log base 3 of 1 is 0, and 0 plus 1 is 1. So our y-intercept is 0, 1. Now, as for the domain and the asymptote, notice that this time I'm graphing a log. So we know the basic logarithm looks like that. Sometimes I call it the swan shape. Looks kind of like a swan head. This time, we don't have a horizontal asymptote. We have a vertical asymptote. So we're going to add vertical to right there. We have a vertical asymptote now because it's a log, not an exponential. And we also notice that the domain is not negative infinity to infinity like it was with exponential. Domain for logarithms is different. Now, domain was actually probably the trickiest part to find. So we're going to practice domain itself for a little bit up here. We're just going to practice finding the domain. Now, if we look at the domain of the regular graph, this domain is 0 to infinity. That's the part of the graph that is here. It goes from 0 up to infinity. Notice 0 is not included. So basically, this domain here is anything greater than 0, which fits. We know that with logarithms, we can't plug negatives in. The inside of the logarithm must be positive, greater than 0. So that is how we're going to figure out the domain up here. Basically, our domain is where the inside of the log must be greater than 0. Because if the inside is greater than 0, that means it can't be negatives, and then that's what we want. We don't want any negatives in here. So we're going to say the inside, I'm actually going to do B first. The inside must be greater than 0. And now we solve. Times by 2, so I get x must be greater than negative 2. So if I write that in domain, if I want x greater than negative 2, that's going to be negative 2 to infinity. And you'll notice, hey, this is the same one we were just graphing. Same equation. So our domain is negative 2 to infinity. Now, here's the nice perk about finding our domain. It's a little harder to find. We have to do that inside greater than 0. However, it will automatically tell you where the vertical asymptote is. If my domain goes from negative 2 to infinity, then that vertical asymptote is at negative 2. So let's see how this graph looks. I have this vertical asymptote at -2. I want the graph to go from -2 to infinity. I need to have an x-intercept here at -4/3. Let's make that green. And a y-intercept here at 1. Make that blue. And I can see my swan graph. Come right here, there, and we're done. Graphed. Check. So that is our first example of solving a logarithmic graph. However, this is a pretty basic one. So let's go back up here to domain and do a couple more complicated domain problems. So let's start with this one. Now remember, for domain, we're going to set the inside to be greater than 0. So the inside is greater than 0. So I'm going to -1. I get x squared is greater than -1. And I'm going to square root, and dang it. Cannot square root a negative. That doesn't work. So in this case, our domain is actually -infinity to infinity. It's all numbers. And here's why. Any number I plug into here is going to get squared, which will turn it positive. So there is no way I can have a negative number in this logarithm, because any negative number I pick, say -5, if I plug -5 in, I'm going to square it, and it turns positive. So there's no way I can put a negative inside that logarithm. Let's try another one. Take the inside, set it greater than 0. Now pause before you start going on this one. This should look very familiar to lesson 3.4. This is actually a sign array problem, where a fraction is greater than 0. So let's review sign arrays really quickly. Sign arrays, our first step was to bring everything to the same side. Check. Our second step was to highlight what we're solving for. I want my positives greater than 0. Third step was to factor. Don't have anything to factor in this one. Fourth step was to find our x-intercepts and vertical asymptotes. X-intercepts set the numerator equal to 0. Vertical asymptotes set the denominator equal to 0. Then step 5, make your sign array. So I have -1 and 0. And now I can do my number lines. So this is a positive section, negative section, positive section. I am looking for my positive sections. So these positive sections right here are my domain. My domain is -infinity to -1. That is where the inside of this log is positive. And from 0 to infinity. That is the other place where the inside of this log is positive. And notice we used parentheses, not brackets, because it's not equal to. So those are a couple more complicated domain problems. Let's end by doing this problem. I would like you to pause the video and for the first time, try finding these things on your own. And then come back and see how it goes. Let's check what you got with what I got. So our domain, we set the inside to be greater than 0. With absolute value, you need to split it up into 2 equations, where one equation is the positive answer and one equation is the negative answer. Now with 0, you can't really make it positive and negative, it just stays 0. However, for the -1, my sign inequality will flip. So that gives me x greater than 1 and x less than 1. So that tells me my asymptote is going to be at 1. X-intercept, set it equal to 0, change the form. 10 to the 0 is 1, and then once again, because it's absolute value, split it up into the positive answer and the negative answer. So I get 2 x-intercepts at 0 and 2. And y-intercept, plug 0 in, and once again I get that at 0. So I have this graph. It might be kind of hard to see it exactly what this looks like at this point. If you needed to make a t-table to plug some more points in to confirm what this graph looks like, you are more than welcome to. But if you did a t-table to get more points, you would actually find that this is what this graph looks like. So that is it for us for graphing logarithmic equations. You are officially done with lesson 4.4. Good job.